All right. Welcome, everybody, to chemistry class. How's everybody doing? If you're there online, just say hi in the live stream chat. All right. So let's go ahead and get started. There was no homework for you to hand in today, but that didn't mean that you weren't supposed to do anything. Hopefully you guys checked out. I know I didn't put them up right away, so sorry about that, but hopefully you guys checked out those videos that I sent you guys talking about logs and talking about that kind of stuff. And that's going to help you guys out for today, okay? So I wanted to give you guys a little bit of time to just do a little bit of background stuff because we are going to be calculating pH today. And in order to calculate pH, you're going to need to know a little bit of a background of logs. And I think that most of you guys have not actually done logs in your math class, which is a little bit unfortunate. But hopefully the videos helped a little bit, at least, to give you guys some background of why they're important. Okay, so in general, in science, these log scales, you have a number of things, right, that have a logarithmic scale in science. And the reason for this mainly is convenience, okay? And so some of those things that you guys have heard about, for example, are the Richter scale for earthquakes. You have the decibel scale for sound. You have the pH scale, right, for chemistry, for acidity. Okay, so this is basically your acid base scale. This decibel scale is for sound, and this is for earthquakes. And I want to give you guys just a little bit of an introduction to this whole pH calculation by talking about log scales so you can kind of put them into perspective. All right, so the log scales help us in order to figure out, how powerful something is in a kind of a different way, right? So normally in an everyday thing, if something has a level of 4, you think that's twice as much as a level of 2, but that's not the case for log scales, right? 4 is actually going to be 100 times more than 2 on a log scale. So on a Richter scale, if you're talking about, let's say, an earthquake, so an earthquake has a value, and I don't even know exactly how they would write this. So your earthquake, you have, let's say, one's a 7 and one is a 6. So in your reading, you learned that the 7 is actually going to essentially move the Earth 10 times as much as the 6. So it's not exactly powerful. It's actually 7 is like 30 sometimes more powerful than the 6, but it's going to move the Earth 10 times more than the 6 earthquake. So a 7 earthquake is going to move 10 times more. On the decibel scale, now it's because of the deci in the front, it's a little bit different, but it's the same idea, right? So let's talk about sound, all right? So if you have an 80 loudness, well, what's that going to be? That's going to be 10 times as intense in terms of the intensity of the sound as 70 decibels. Okay, 80 decibels is going to be 10 times as loud as 70. It's going to be 100 times as intense as 60 decibels. Okay, and so each 10 in this case is 10 times more intense. All right, it's going to be exactly the same as the Richter scale, except you have a 0 at the end. All right, so and makes it a little bit different in that respect. But it's just 80 is going to be 10 times as intense of a sound as 70, and it's going to be 100 times as intense as 60. So let's talk about pH. pH is what we really, really care about, because that's what we're talking about in terms of acids and bases. So let's suppose you have a pH of, let's say, let's do it down here, 1, 2, 3, 4, 5, all right, whatever. All right, so let's compare everything to a pH of 5, all right, and say, okay, a pH of 4 is going to be what? A pH of 4 is going to be 10 times as acidic. And you'll know that this works a little bit backwards. So as you go down in pH, it becomes more and more acidic. A pH of 3 is going to be 100 times as acidic. A pH of 2 is going to be 1,000 times as acidic. And a pH of 1 is going to be 10,000 times more acidic than pH of 5. Okay? And so this log-based scale, these pH Richter decibel scales, these scales are such that when you go up or down 1, you have a 10 times difference. Or for the decimals, when you go up or down 10, you have a 10 times difference. And this is convenient when you have something that can vary a whole lot and you want to just be able to deal with normal numbers, right? Not say, okay, that's a 1 million earthquake, or that's a 10,000 earthquake, or something like that. You want to just deal with something, just a nice round numbers, right? 1 to 10, something like that, all right? And so that's the whole purpose of these log scales. And I do expect you guys to be able to do this for pH. And so I can tell you any random 2 pH values, right? Let's even do right now. Let's compare 2 pH values, and I want you to tell me how many times more acidic is one is than the other. So let's say we have a pH of 6 and we have a pH of 4. Well, first of all, which one's more acidic? I got 12 of us. All right, great. We have a nice crowd today. Which one's more acidic, pH of 6 or pH of 4? You guys, anybody with me here? I know you're online, so somebody write a comment. Which one's more acidic, pH of 6 or pH of 4? And somebody else can write, okay, how many times more acidic is it? How many times more acidic is it? All right, 4 is more acidic. Yes, that's going to be more acidic. And how many times more acidic is it? 5, 4. So it's 2 steps. So this is going to be not 10, but 100 times as acidic. Why? Because when you go down from 6 to 5, you're now 10 times more acidic. Then you go from 5 down to 4. Now it's going to be 100 times more acidic. So each step in pH is 10 times more acidic. Right? Each step in pH is 10 times more acidic as you go down, and so you just multiply them, right? So pH of 6 and 4 is 100 times more acidic, all right? And so we'll do some more review questions like that, but you're going to probably you will get a question like that on your quiz on Wednesday. So make sure you understand the basics of that, all right? We will get into some more difficult things that we're not going to necessarily cover on the quiz, but this you should know. All right. Yep, 10 for each step, 10 times each step. Each time you go down a step, it's going to be 10 times more acidic. All right, so there's no homework due today. Hopefully you guys got a little bit of background, and we're going to get into talking about, this is the, I wonder if this is the right one. This is the wrong one. I got the, oh, this is just great. I got the wrong homework written out here, printed out. So that's fine. I'm just going to write on these blue sheets, and we'll talk about acids and bases and talk about pH. All right. So I'm going to give you guys a little introduction to logs. I think you guys have already had somewhat of an introduction, but I'm going to give you guys a little bit more introduction, and then we'll talk about calculating pH, and then I'll give you guys, we'll look at the homework problems together here. Okay. So, all right. So logs, like we said, are this scale where each step is going to be 10 times more, 10 times less than the other step, right? And why is that? All right, what is a log in general? So let's just answer that question. So a log is basically an inverse of the exponential. So you guys have done the exponential things before, and anytime in this class, we're always going to be doing always, in this class, base 10 logs. I know in some of the videos that you guys watched, he talked about other bases, and when you get into math, that's fine. You can do a whole bunch of different bases for your logs. But let's just talk about base 10 logs. So when you talk about, let's say, 10 to the third equals 1,000, let's turn that into a log, okay? So it's going to be log of 1,000 equals 3. It's the inverse of this whole exponential. So you have, in general, log of x, right, equals y. That's going to be the same as saying 10 to the y equals x. All right, so that's it. That's what your log is in a nutshell. And we're always going to do base 10 logs. Now, next, what about pH? Let's talk about pH. So pH is a neat thing, and it has a specific definition. And let me just give you guys that definition of what a pH is. Oops. So pH equals negative log of the H plus molarity. So a couple things I need to first define. What is this whole brackets thing? Okay, in general, so brackets of H plus means molarity of H plus. And so brackets anything, so we could do brackets X equals molarity of X. This whole P thing here. So P stands for power. So pH is not some random thing. pH stands for hydrogen power. So the pH of something is the hydrogen power of something, where the H stands for H plus. So the power of H plus. Right? And remember, we talked about acids, and we said, well, the defining characteristic of this acid in terms of Arrhenius, that is going to be given H plus. In terms of Bronson and Lowry, they said the same thing. It's going to be given H plus. So H plus is your whole acid and base idea. So everything revolves around this H plus. Okay? And so we can calculate it. This is literally a defined a definition of what pH is. So pH is not some scale from 0 to 14. pH is defined as the negative log of the H plus molarity in any solution, whether it's neutral, acidic, or basic. And so any solution is going to have a certain amount of H plus. And so before we go on and actually calculate these, let me dispel some misconceptions, right? So first of all, let me get to what you guys do know. So a pH of what is neutral? Now this you guys probably know. What do you guys think? What is neutral pH? What would you say? Anybody? pH of what? And this is something that I expect you probably should have already known this before, right? But we're getting to new stuff here, talking about the logs and all that. So pH of, I'm not seeing any answers. You guys all know this. Yeah, not 0. 0 is actually acidic. Any other answers? So pH of what is neutral? 0 would make a whole lot of sense, you'd think, right? But it's actually not. pH of 7 is neutral. So maybe you guys knew it before, maybe you didn't, doesn't matter. Now you guys know. All right, so pH of 7 is neutral. And then anything less than that, so if the pH is less than 7, it is acidic. Okay? And if the pH is more than 7, it is basic. Okay? So low pH means acidic. Any kind of low pH, like 1, 2, 3, that's low pH, that's going to be acidic. Basic is any kind of high pH. So when the pH is 10, 11, 12, that's going to be a high pH. Anything greater, oops, did I say right 8 here? This should be greater than 7. Sorry about that, guys. So any pH that's higher than 7 is basic. Any pH that's lower than 7 is acidic. High pH is basic, low pH is acidic. Now, let's get more to this whole calculation because you guys are going to need to calculate some pHs here on your own here. So let's get into the actual idea of, well, why is this whole, how does this pH work and why is the pH of 7 neutral? So you guys can look on your, let me see, you guys can look up on Google Classroom and you should have your homework, your next homework. I'll have to check on that. I can't do it at the same time that I'm looking at this, at your comments here, but you should have that. All right, so question here. I am unable to open my chemistry book and I'm emailed the tech support, nothing yet. Man, that's not cool. The symbols are switched, I believe. The symbols are switched. Which symbols are switched? I don't think so. So, but maybe which symbols? You talk about natural log of something? I'm not sure. So if you talk about natural log of something, we're not going to use natural logs. We're using base 10 logs. And these symbols are not switched. So if you talk about the pH, so low pH, so pH is, if the pH is less than 7, that's going to be acidic. If the pH is more than 7, it's going to be basic. So that's correct. Greater than, less than, nope, it's not switched. This is the way it should be. So pH greater than 7, high pH is basic. So pH of 10 is not acidic, it's basic. Yeah, so pH less than 7, that is acidic. That's the way it should be. Okay? That's okay. It's all good. Good that we clear that up now. All right. So, books. I can't really help you out so much with the tech issues in terms of books. I can say that I'm teaching you guys all the stuff that you guys need to know about pH. You can find my PowerPoints on OneDrive, and you can be resourceful if you can't find the book. But that's an issue we should have taken care of at the beginning of the year. I don't know what else to say. So yeah. So hopefully you get your book worked out and all that kind of stuff. All right, so moving on. So especially for those who don't have the book, we need to really, really pay attention and make sure we can follow along in terms of this whole pH stuff. So let's go on. All right. This whole pH system is based on the fact that water does something interesting. Okay, and what do I mean by that? So water will actually react with itself and it will form H3O plus and OH minus. This reaction right here is known as the auto-ionization of water. Why is that? Auto means self. And we've already learned what ionization means. It means the splitting up into ions. So water will react with itself and form some amount of H3O plus, which is your acid, and some amount of hydroxide, which is your base. And in general, H3O plus is going to be the same as H plus. Why is that? Because H3O plus is simply an H plus that's stuck onto water. All right? So H plus is simply a lonely proton, just a proton all by itself. And when you have H plus and you have H2O, like this, they're going to form a bond, and that H plus is going to stick onto water. Anytime you have H plus in water, it's going to stick onto water, and it's going to make H3O plus. Right? And the overall thing has a positive charge. Okay? So anytime we see H3O plus or H plus, they're the same thing. When you talk about something in water, they're the same thing. Okay? All right. So what am I getting at? So what? Water will auto-ionize and it will form H3O plus and OH minus on its own. Well, so what? Well, this is really interesting because these amounts are known, all right? And so we can measure the amounts of each that we have. Plus, if we add one of these things, let's say I add some H plus to the solution, this OH minus needs to go down. If I add hydroxide, if I add OH minus to the solution, this needs to go down. So they're kind of a balance. And in fact, they always have, and let me write it out here, the amounts are going to be, so the amount of H3O plus you have times the amount of OH minus you have is always going to equal 10 to the minus 14. All right? That is always a constant. Now, you're not going to need to use this equation. All right? We use this equation in honors class, but you guys don't need to use the equation. What do I want you to see from this equation, though, is this, that these things are balanced. Every solution of water has some amount of both of these, okay? So if I increase the amount of acid, the amount of base decreases. If I decrease the amount of acid, the amount of base increases. If I increase the amount of base, the acid decreases. So they're all balanced together so that the product of these two things is always equal to this constant. All right? This is a constant. And which means that what if we have neutral water? If we have neutral water, we have an equal amounts of this and this. And so for neutral water, and you can measure this stuff actually. So neutral water is what? So neutral water means that you have, and you can measure it, an equal amount of H3O plus and OH minus, and it must be 10 to the minus 7. So that's the amount that you have, 10 to the minus 7 moles per liter, okay? In neutral water, all right? So again, guys, this is just background, so you're not going to necessarily have to use this equation, but this is just background. So in neutral water, you have 10 to the minus 7 this and 10 to the minus 7 that. You have both of them. Well, let's do our first pH calculation and calculate the pH of neutral water. Let's all do it together. So get your calculators. And this is going to be key because the log concept, this is not math class. We're not going to have to do any kind of crazy log rearranging and all that kind of stuff. You just need to be able to type it in your calculator and you'll be good to go. That's it. All right? So I'm done with the theory. Let's go to the calculation side. All right? So this is going to be your first ever calculation. And let's look back at how do you calculate the pH. Let me just start with a fresh sheet here. How do we calculate pH? So we have neutral water. It means that we have equal amounts of these things. And so in neutral water, we can go ahead and calculate the pH of neutral water. We have the equation pH equals negative log of my H plus molarity. And let's try it in my calculator. So I've got negative log. You guys all find your LOG button in your calculator. All right? Capital L, capital O, capital G. All right? Not your natural log, not some other kind of log, your LOG log. All right? Find that in your calculator. So to calculate pH, we do negative log, and then we're going to write in the H plus molarity. Now I said it's 10 to the minus 7, and you can write this two different ways. You can write it as your 10 to the minus 7 like that, which is probably going to be the way that's going to make the most sense to you. And let's go ahead and enter. This is going to be the first time we ever calculate pH of anything. We're going to calculate the pH of neutral water. We hit enter, and we get the number 7 out. Well, look at that. Why is the pH of neutral water 7? The pH of neutral water is 7 because neutral water has 10 to the minus 7 H3O plus in it. 10 to the minus 7 moles per liter H3O plus. It's a measured amount. It's not some random thing that people took and put on a scale. It's a measured amount. And so this, for neutral water, pH equals 7. Okay? And so when we realize that the reason the pH is 7 is got to do with how much H3O plus there is in neutral water, then we can start to think about, well, what is pH scale, right? You may have been taught that pH scale is just some scale. Let's say maybe you've taught from 1 to 14, or maybe you've been taught it's from 0 to 14 or something like that. But I'm going to tell you guys, it's not really true. Why is that? You might be wondering, or maybe you're not, that pH, can you have a pH of 15? Is that possible? Can you have a pH of -1? Is that possible? And the answer is yes. Okay? It is not a scale from 1 to 14 or a scale from 0 to 14. You just typically find that things have a pH that's in those ranges, but it is certainly possible to have a negative pH, and it's certainly possible to have a pH of 15 or even more. Okay? So pH does not have to be in this particular range. So it is true that pH of 7 is neutral, but it's not true that the scale just goes from 0 to 14. All right, so we're going to go ahead and X that out and say this is possible. Possible to have negative pH, possible to have a pH greater than 14. So with that said, let's go ahead and do some pH calculations. And I don't actually have the homework in front of me because I printed up the wrong thing. And so we're going to go ahead and just do some sample pH calculations together. And unfortunately, they're not the same ones that are going to be on your homework, but maybe they are. I think I can remember some that might be. So let's calculate a whole bunch of pHs together. So we want to calculate the pH of the following acids. All right, so we have, let's see, 0.001 mole per liter HCl. We have 0.01 mole per liter HCl, 0.1 mole per liter HCl. How about, let's do all these and find out what's the pH of all these. Okay, so first thing I want you guys to realize is that when you have an acid, we're like, Mr. Katz, how do I know whether I have an acid or not? Well, first of all, HCl is something that we've seen before. It's one of the 5 or so common acids that I told you guys about. Secondly, we notice that this HCl has an H in front. And the H tells us, okay, that is an acid when it has an H in front. All right, so we're going to calculate the pH of acids first, then we'll go ahead and calculate bases, the pH of bases later. So when you're calculating the pH of an acid, we're going to use this equation, pH equals negative log of the H plus molarity. The H plus molarity is going to be the same as the acid molarity. As long as it's a strong acid, which you will always have for me. You're always going to have a strong acid. All right, so let's go ahead and do it in your calculators. All right, so we have 0.001 mole per liter HCl. So let's do negative log of 0.001. And do this in your calculators. Don't just watch the video. Actually get your calculator out. If you don't have your calculator, go grab it right now, okay? And get your calculator out and try this, because if you can't put it in your calculator, you're going to need to figure out how to put it in your calculator somehow, okay? So negative log of this value, boom, that's the pH. The pH of this is 3. Okay, let's try the next one. Negative log of 0.01. I don't even need to end my parentheses. I'm just going to hit enter. That's going to be 2. How about this one? Negative log of 0.1. Look at that. That's going to be 1. So very quickly, we've answered the pH of 3 different solutions. And we notice something also very interesting about them, right? This one is 10 times more concentrated than this one. And we notice that the pH goes down by 1. This one is 10 times more concentrated than this one, and we notice that the pH goes down by 1. Remember what I said, that a step in 1, going down 1 in pH, is actually 10 times more acidic. I have 10 times more acid in this solution than I have in this one. All right? How about the next one? 1. The log of 1 is what? Let's try it out. Negative log of 1 is 0. So we have a pH of 0 in this case. Can you have a pH of 0? Yes, most definitely. You can have a pH of 0. And the pH of 0 is 10 times as acidic as a pH of 1 because there's 10 times as much stuff in there. Let's keep on going. We have a 10 mole per liter HCl. Let's try negative log of 10. Well, what do you think? Make some guesses. What do you guys think is going to be? Either calculate it or think from this pattern, what should it be? I'm now 10 times more acidic, so what should it be? Let's hear your answers before I hit enter. Negative 1, you are right. Negative 1 is the correct answer. And you might be saying, is it possible to have a pH of negative 1? Yes, it is certainly possible to have a negative pH. Negative 1 is possible. You can make the solution. Now that's fairly concentrated, and you don't want to get that stuff on yourself. It will burn you pretty darn bad. All right. So that is that's pH in a nutshell there for acids. Now what if we don't have a nice number? You're not always going to have a nice number. Let's try something that's not nice, not like a 10, 1 kind of thing. Let's try point, and I'm just going to make this up, 0.0385 mole per liter. And let's use a different acid. It really doesn't matter what the acid is. HNO3, that's nitric acid. And let's see what that is. Now we're expecting, because it's not like a 1 here or a 10 here, it's not going to be a nice number. And that's okay. Okay? So let's go ahead and do that. Same exact equation, still negative log, and we just put the number in, 0.0385. I hit enter, and that's my number. Don't know if anybody got it, but the pH is 1.41 whatever. And I'll go ahead and write that down. We're not going to worry about significant figures for these, but just make sure that you give me some numbers after the decimal. Don't just say, oh, my pH is 14, because you have to write the other stuff down. So give me at least 2 numbers after the decimal point, but normally I'm going to want 3 numbers after the decimal point. I want all this detail, all right, so I can make sure that you guys are getting the right answer. All right, don't just write 1, a pH of 1. That would be wrong, okay? So if you write 1, I'll mark it wrong. Now, if you write 1.4, I'll give it to you. But don't just write 1. Don't round it off to a whole number. Your answer will be marked wrong, okay? So 1.415 is the pH of this solution, all right? So next up, let's talk about bases. So you do need to be able to calculate the pH of a base, and calculating the pH of a base is similar, but there's a different equation. So, calculate pH of a base. What do we do about bases? The equation for the base is going to be this. All right, so pH is going to be 14 plus the log of the OH minus. All right, and this OH minus is what? That's going to be your molarity of the base. Now this is a derived equation, and I don't really want to get into the theory right now of, okay, well, where'd you get this equation from? I could derive it for you guys, but it comes from the other equation, and it comes from that kind of relationship there that we had. So if you recognize this 14, it comes from that 14 we had before, of why the H plus times the OH minus is going to be 10 to the minus 14. So that's where the 14 comes from. But you don't need to worry about that. All you need to worry about is, can you put this in your calculator? And that's it. So let's try it out. Let's suppose we have 0.001 mole per liter NaOH. Well, first of all, how do you know that this is a base? Well, you look right here and you see, okay, There's O. There's an OH there. That's a hydroxide. So that is the indication that this indeed is a base. And you're going to use this OH minus equation. Okay? So let's calculate the pH of that using this equation. And let's suppose you mess up. Let's suppose you use the wrong equation. You go negative log of 0.001, hit enter, be like, oh, it's a pH of 3. No, it can't be a pH of 3 because sodium hydroxide is basic. You have to have a pH greater than 7 here, and so it's not going to be a pH of 3 for this. So that's wrong. All right, so we're going to use the base equation, and that's going to be 14 plus the log of the base molarity. That's going to be 0.001, and that gets me 11. Right, and that makes sense because it's greater than 7, so it's basic. So that has a pH of 11. How about, let's see if you guys can do this in your head. 0.01 mole per liter NaOH. What should the pH of that be? What do you guys think? What's the pH of that going to be? A bit tricky, but we know if we're 10 times more concentrated, it's going to be 10. It's going to be you're going to be 10 times as basic here, or 10 times less acidic, and so it's actually going to go up in pH. So it should be 12. Let's see if that's the case. 14 plus log of 0.01 gets us 12, and that is correct. Okay? All right, 12, nice. If you got 12, you are nice. All right, let's try a couple more, and then we'll just end there for the day. There might be some problems in the back that are a bit tricky to go through. Don't worry, the problems in the back will not be on your quiz, and we'll talk about them next time. Okay? So just make sure you finish the front side for tomorrow, and we'll talk about the back tomorrow. All right? And we'll have a quiz on Wednesday, and the homework will also be due Wednesday. Or I can make it due Thursday. Quiz on Wednesday, homework due Thursday. That's fine. All right. So enough said. Let's do a couple more. Let's do, how about 10 mole per liter NaOH? Well, what's that going to be? Let's try another one. Let's do 2 at once here. See what you guys come up with. So 10 mole per liter sodium hydroxide, and how about 0.0593 mole per liter? Let's use a different base. Let's use KOH. All right. Now it doesn't matter what base you have, the equation is still going to be the same. And so yes, I'm getting some good answers here. So somebody wrote 15, and that's exactly right. Let's try it. 14 plus the log of 10 is what? That's going to be 15. Yes, you can have a pH of greater than 14. When you have a highly concentrated base, it will give you a pH that's even greater than 14. All right, and then last one here, we've got 14 plus 0.0593. Oops, forgot the log, plus the log of 0.0593. That's going to get us 12.773. All right, 12.773. I like you to write all these decimal points, or all these digits after the decimal point, but give me at least 12.77, okay? Give me at least 2 numbers after the decimal point, and you'll be good to go, all right? So we're just gonna end there. I know there's the whole backside that we didn't talk about, so don't worry about the backside. Do the front side for homework for tomorrow, and then we will talk about the rest of that homework. And we'll talk about the quiz also, all right? So see you guys tomorrow. Have a great rest of your week, great rest of your day. Peace.